शुरू हुआ सर।
अच्छा,
पूरा मूवी का मजा फर्स्ट टाइम। Key Director and Chief Vigilance Officer. Sir has a remarkable career in teaching, research and administration. He has published over 150 research papers in reputed international journals, national journals and conferences. Sir having author of 6 books, 2 granted.
Facing challenges while transiting from grid connected from the island and mode of operation. This is what I have taken to my research study, the islanding detection. The research motivation behind this islanding detection is it reduces or it safeguards the danger to the maintenance and restoration personnel. It also reduces the distraction of both the customer and utility side equipments. The power quality of DG become worsen and adversely affect the loads as and when there is a islanding, and it automatic closing of utility breakers may create a condition of asynchronous closure. So based on all these, all these points, I have considered this. This is a research motivation for me. Now let's see what is islanding. So as per IEEE standard 1547, the condition in which the part of the system becomes isolated from the rest of the network and the separated part is operated with at least 1 DG. So in the leftmost figure, the grid is disconnected. At the same time, the local DG is continuous supply to the local load. So this is what the condition where we call it as a islanding in the power system. So there are 2 types of islanding. One is intentional islanding and another is unintentional islanding. So intentional islanding involves deliberately isolating the portion of the grid, allowing to operate independently with the local generation sources. It is specifically for any maintenance operation or anything with regards to to disconnect the system or a part of the system from the utility grid. With regards to the unintentional islanding, it occurs when it becomes isolated inadvertently, means haphazardly it is disconnected from the utility grid and yet to continue that is the local DG supply to the system. This process safety hazards and can lead to equipment damage due to the unsynchronous operation of the system equipments. Let's see the issues with the unintentional islanding. It harmful for the equipment which are connected in the system. It also performing the malfunction in terms of reclosure. It also increases the risk of tripping. Safety hazards also with the utility worker, as well as it will be harmful to the sensitive loads which are there in the system. Now let's see the islanding detection method classification. So the detection methods are classified into conventional and modern islanding detection methods. In the conventional, we have the remote islanding and the local islanding detection methods. The local islanding detection detection classified to the active and hybrid. In the modern, we are having a signal-based methods as well as intelligence-based islanding detection methods. Let's see with regards to the islanding detection methods. So remote islanding detection methods includes remotely operated. It receives the signal from the remote locations to the receiver, as well as accordingly what parameters are there with regards to the system. It is going to isolate the system that is part of the system from the utility grid. It having merits like high reliability in terms of non-detection zone. There is a nil non-detection zone. It can be scalable from the system. It comprehensively monitors the system as well as it is versatile. In terms of demerits, the most important demerit with regards to the remote detection method is high implementation cost. It also depends on the communication system. It is complex to implement as well. It is having latency issues. Also, it requires high maintenance. So because of this, remote detection method is one of the most accurate method, but due to the high cost and the other demerits, it's not there much in the implementation. Going to the next, that is islanding detection methods. It includes many of the islanding detection methods. which are measuring the parameters at the common coupling in terms of voltage, current, power frequency, phase angle, etc. Then it will get compared with the threshold values, and then after it will send the signal to the aligning detection circuit by which a part of the power system that is isolated from the utility grid. We also having some merits, simplicity, no active power injection, low maintenance, fast response, and is widely adopted throughout the system. It also having demerits like higher non-detection zone, false positive, limited reliability, insensitive disturbances, not scalable, as well as depending on the threshold value setting for different parts of the power system. Moving towards the active aligning detection methods. It is injecting or it is introducing perturbation into the system at the point of common coupling. Then as and when there is islanding, the perturbation signal will be magnified. And this is how we are detecting islanding by comparing the threshold values, and the signal will be sent to the circuit breaker. Moving towards the merits and demerits of active method, high sensitivity, reliable performance, detection, scalability, and it's well proven in the practice. The demerits, it is with regards to demerits, it is hampering power quality. It's a complex to implement. We having energy losses as well as negative also coming across whenever there is a detection part of aligning methods. Also, it is incompatible with the weak grids. Coming to the intelligent methods, so with the help of measurement of PCC, we analyzing the signal in terms of different processing methods, and accordingly we train and test the algorithm and will come across the decision. We are having merits like high accuracy, minimal non-detection zone, scalable, and it also handles complex scenarios. In terms of demerits, high competition requirement, data dependency, implementation complexity, as well as the constant to implement intelligent detection method. With regards to the signal processing, the signal is measured at the PCC, and it is analyzed to different signal processing techniques. Accordingly, it is compared with the set threshold values. And if there is a exceed of threshold value, the IDM signal sent to the breakers by which the part of the system will get disconnected from the utility grid. It is also having merits and demerits like high sensitivity, fast detection, no indicate present here, effective for complex scenarios, adaptability, preservation, as well as demerits of high complexity, data quality, implementation, scalable issues, latency in the real time. So these are the merits and demerits about the signal processing system. Now, with regards to the hybrid detection method, where I implemented a same sort of system. Here actually two methods combined together for detecting islanding in the microgrid, where initial part where two methods combined either active or any of the method which I have explained just now. So if we combine two methods, we will have the merits of both of the methods by which we can have most efficient islanding detection method for detecting islanding in the power system. Now, with regards to the performance analysis of islanding detection methods, we have few performance indices. The first performance indices is the non-detection zone. This is what the range of condition in which the IDM fails to detect islanding event. On the x-axis we are having change in the active power. On the y-axis we are having change in the reactive power. So the square is there on the screen for both of the graphs. Inside that square, the IDM unable to detect the islanding, where outside that particular square or the zone, the method can detect the islanding. Even with that, we having few of the performance indices to check the quality of the implemented IDM. The first is detection time. It is the interval between the aligning event as well as to the detection of IDM. It should be a rapid detection essential to comply with the standards IEEE 1547, in which it mandates with regards to the time that there will be a maximum 2 seconds to detect the IDM occurrence till the separation of the microgrid. There should be minimal impact on the power quality by implementing IDM algorithm. It should be in multiple scenarios, as well as error detection ratio is also expected to have a low. With regards to literature review, what I've studied where I've studied different peer-reviewed journals, I found different aspects of the implemented work in terms of the implementation of microgrid, as well the implementation of different detection methods which I've explained just now. So I've studied all this literature just to have a broader sense of background for my research proposal. In this literature review, I've gone through different references. I've compared different references to the non-detection time, working with the multiple DGs or not suitable for small-scale synchronous generator-based generators, as well as inverter-based microgrid generators. I also reviewed the dependency on XY ratio. I also studied whether implemented method is effective in the weak stronger. Also, the impact of quality I've studied in that. So these are what the different literature I've studied, in which I've compared the passive, active machine learning based signal processing and the hybrid methods. Out of the literature we have studied, I've highlighted some of the challenges for the aligning detection, where it comes from all the performance indices, non-detection, quality degradation, implementation computational burden, multi-DG efficiency, quality factor of the load, fault detection zone, cybersecurity, and the stability concerns. So while designing a method for the hybrid microgrid, it requires us to look all these concerns by which we can have effective implementation and design of aligning detection method. So these are the recommended standards for the aligning detection. So IEEE 1547 is mostly referred standard to the connection of DGs to the microgrid. So throughout the literature, the gaps which I found out is the most of the IDMs are primarily designed for the traditional power system or the microgrid system that are solely inverter based. This limits their applicability in the complex environment of microgrid, which combines synchronous and inverter-based DGs, posing particular challenge not sufficient by existing detection methods. With regards to the passive IDMs, which are not sufficient or insufficient for the scenarios involving the balance active loads, reactive powers, and the development NDZ hybrid microgrid. Despite the increased robustness, with regards to the active IDMs have the potential system disturbance like frequency deviation, because it is adding a disturbance into the system by which it will get magnified at the time of detection of islanding, and that can be compared with the threshold values. As well as hybrid microgrid increasingly digitalize the signal interface and cybersecurity vulnerabilities are major practical issues for the communication-based IDM hybrid microgrid. The hybrid aligning detection method aims to leverage the strength of the passive and active techniques. Even earlier implemented objectives of my research proposal are aligning detection AC/DC microgrid by using a hybrid method, performance analysis of IDM performance indices, and the comparison analysis for proposed hybrid IDM with the existing IDM AC/DC microgrid based on the performance indices. Now I have selected two methods. One is active method and one is passive method. I'll explain with regards to the significance why I selected these two methods. One is IB, that is intermittent bilateral reactive power variation. And this is the active method. The second is ROC, rate of change of phase angle difference. This is the passive method. The active method which introduces into the system, and the passive method is just monitoring the parameters at the PCC. I've tested with the different combinations with the different parameters like detection time, accuracy, in the noisy environment, and a false positive. When I've checked IBRP's performance with the voltage based passive methods, it is in terms of detection time it is slower. The detection time is very high. The voltage changes are not be precise for dynamic detection. Less effective in the noisy environment and sensitive to the normal voltage. So these are what the limitations why we haven't gone for combination of IBRP with the voltage based methods. The next is IBRP with the frequency based passive method, where the frequency changes are gradual, which is impacting the detection time. That is detection time is higher in this combination. The frequency variation not always clearly indicating the islanding. It struggles with the high noise conditions. As well its false positive rate is impacting to the load changes. Now to the next combination, IBRP with the harmonic-based passive method. Harmonic changes can be gradual and less immediate, which is impacting the detection time. The analysis can be less sensitive. Is affected by the noise and non-conditions. It depends on the various system parameters and the factors. So the method which I have implemented for hybrid microgrid is hybrid IDM, which combines IBRP with the ROC pad, which gives a quick response due to the ROC phase angle deviation. As and when there is islanding, it is impacting on the phase angle. And in passive method we have calculated rate of change of phase angle difference. So it gives a quick response to detect the islanding, as well as its detection accuracy is increased when both methods are combined together. Its sensitivity and the frequency measurement provides the robust environment, as well as its false positive is very negligible. So that's why we have selected a combination of IBRP with the ROC pad. IB once again explaining IBRP is the active method which introduces the perturbation into the system, and ROC pad is the passive method which is just measuring the parameters at the PCC. Depending on the signal provided by ROC pad, the IBR will get activated and it is going to introduce perturbation into the system. Now let's see the design of the IDM method, which includes passive method and one active method. So as far as the working algorithm is concerned, on the left hand side there is a measurement of voltage and current at the point of common. It is going to calculate the ROC pad with the measured values of voltage and current. Then it is compared with the threshold values of the ROC pad. If the threshold is exceeded, it will activate IBRP, that is intermittent bilateral reaction, to introduce perturbation into the system. Then as and when the active method is introducing perturbation into the system, the frequency parameter is checked for threshold value. As and when there is a variation threshold value of the frequency, then it will send a tripping signal to the islanding breaker. The passive method, as already explained, having high sensitivity detection time, it requires minimum hardware, and it is also not impacting much on the power. Whereas the active method, the intermittent bilateral reaction, it introduces signals into the system. As and when there is signal from the ROC pad. Sir, one second. Just forward connect the charger. Thank you, sir. More detailing about the passive method which we have used in this particular hybrid IDM. It monitors the phase angle difference at the thesis in terms of monitoring the current signal. Under normal condition, the phase angle difference is relatively stable. It's close to zero. However, during the aligning events, as it is disconnected from the utility grid, the hybrid microgrid creates a significant change in the phase angle difference. And by calculating the rate of change of phase angle difference, we are checking its value to the threshold value. It is having demerits and merits like the passive method I have explained. When I analyze the performance of the ROC pad in terms of the power variation and changes in the load, so I've got these results that irrespective of the mismatch varying from 5% to 40% in the system, very minor changes in detection time. This is highly. I mean, the detection time is very less, as well as even for the second case for the load change. In this case, also there is very little bit impact onto the detection time of this particular passive method. With regards to the active, that is intermittent bilateral variation, it operates intermittently in the reactive power variation with both inductive and the capacitive direction at the inverter's output, enhancing the detection sensitivity to voltage and under voltage conditions. It is deliberate fluctuation in the system voltage and frequency. Under normal condition, there is no perturbation introduced into the system by the active method. As and when there is a aligning detected by the ROC pad, there will be perturbation introduced into the system, which is of both nature, inductive and capacitive nature. With regards to the design of IBRPV, I've considered parameters on frequency, quality factor, the resonant frequency. It will use accurate calculation for F0, and it is essential for understanding how it behaves under aligning condition. The quality factor is also important parameter while designing active method for aligning detection. The high quality detection harder due to the non-detection zone. So as per the standard maximum value we have to consider for test the system is 2.5. So that maximum value is considered to test the design hybrid IDM. With regards to the minimum disturbance, that is quality means Q disturbance, which we have introduced into the system in terms of negative and positive reactive power. With regards to the non-detection zone, it ensures how it will detect into the operating region as well as how it is impacting onto the lower region of I-landing. The sigma is a parameter which will contribute which is derived to detect the values for the non-detection zone. With regards to the hybrid method, I've combined two methods. The first is the passive and second is the active. As and when there is a detection of I-landing from the ROC, which is a passive method, there will be perturbation from the active method. Then the detection time is much shorter to the active methods. The operation of the active method is synchronized with the passive method. As and when there is a detection from the passive method, the active method will be operated. In normal condition, active method is not in the picture. This is what is the hybrid microgrid. In which there is a utility grid, AC microgrid. I have considered diesel power plant, wind power plant. Also the solar photovoltaic power plant 27 kW, supercapacitor and fuel cell onto the DC microgrid. With regards to the specifications of the design system, the microgrid is of AC microgrid is of 450 hertz, DC microgrid is of 300 volts. The diesel generator is of 11 kilowatts. Wind generator is of 22 kilowatts. Supercapacitor 99.5 farads. And the fuel cell is of 6 kilowatts. The solar power system which have designed in this hybrid microgrid is of 27 kilowatts. Double stage forward bidirectional converter with the decoupling control. This is the metrology, the actual implementation of the proposed hybrid islanding detection. So the initial leftmost line where the ROC pad detects the islanding. As and when there is islanding, there will be detection by the ROC pad. As and when there is detection by ROC pad, it will send a signal to activate BRPV. Activation of ROC pad and activation of BRPV. As soon as the ROC pad will activate the BRPV. So it's on the same age. So these are the design parameters which I have considered to design a hybrid IDM. A tripping signal can be triggered by setting a threshold value of 40 degrees per second. For relay operation, the reaction time can be changed by only 3 milliseconds when the threshold is changed between 50 to 100 degrees per second. The time constant for the first order filter for the current regulator is 0.001 and the PR regulator parameters KI is 2000 and the sampling time is 70.4. The perturbation time from calculation is 150 milliseconds. The quality factor is set to the higher value, that is 2.5 according to the requirement of 1547, as well as maximum minimum values considered 50.5 and 14.5. So accordingly from the calculation, the power reactive power needs to be introduced for the active method is the 5% of the total active power of the system. The performance of design IDM is tested with all these test conditions. The first islanding detection test is carried out. Then large load switching test is carried out. Non-linear integration test. Grid voltage test, power quality impact, and the performance under the varying load conditions. As far as islanding is concerned, the design hybrid IDM detects the islanding in case of islanding, that is unintentional islanding. For the rest of the cases like large load switching, non-linear load integration, grid voltage dip, as well as power quality, it is not going to detect islanding. That is, it is not going to send signal to the breaker which will isolate the hybrid microgrid from the utility grid. So this is a result for the islanding detection test. So islanding event is created at t is equals to 4.5 seconds. So as and when there is islanding event, it is impacting onto the initially it is impacting onto the rate of change of phase angle difference. Then it is impacting onto the frequency. As and when there is impact onto the frequency, that will be the responsible for the final signal to the breaker. If we have the signal from the ROC pad and if we won't have activation of IBRPV, there will be no islanding detection. Now in this condition, what the islanding event is considered. I mean created in the power system. In this first initially ROC pad is activated, then it signal to the IBRPV, and it will introduce perturbation by introducing a signal to the current regulator, which will add active and reactive power in the both sides of the system. As and when there is perturbation introduced in terms of active and reactive power, the frequency parameter will get distorted, and it will be compared with the set threshold, and it is exceeding the set threshold. That's why it is detecting. It is sending a islanding signal to the breaker. With regards to non-load integration, so 10 kilo of non-load is injected into the system at 0.45. So this is a load integration test to the system. So as this is not islanding, it just have the its impression and its impact on the frequency, but it is low to the threshold value. Therefore, there will be no signal to the IBRPV, as well as there is no detection signal for the circuit breaker. Then with regards to the lateral switching, this is also a non-aligning condition where 60 kilo of load is near to the DCC and disconnected at 0.45 seconds under grid connected mode. As grid is connected, there will be very negligible impact on the system. Whichever cases are considered, in these cases the utility grid is connected to the system, and therefore there is very negligible impact onto the frequency parameter. Then a grid voltage dip test. So a two-phase short circuit fault has been created, and which is responsible to have the voltage dip. So once again in this there is no frequency deviation beyond the limits, and it is not detecting a scenario as an islanding scenario. In terms of power quality impact, because of implementation of IBRPV, there is very less impact onto the power quality. In terms of TSD, have measured impact is 0.70%. So it is very less as per the recommended standards. Now also have tested the performance under the varying load conditions. So I've varied the load from 10 kilowatts to 25 kilowatts, which is closer to the 100% load of the solar photovoltaic system. Even I've checked for inverter, active power as well as the inverter. The key observations what I made from the variation of the load is as load increases from 10 to 25 kilowatts, detection time consistently decreases for the both lagging and leading power factor. For the lagging and leading power factors, the impact onto the power factor detection is slightly faster for leading power factor, and due to the improved system stability and disturbance characteristics. In terms of detection time, it is consistently identifies detection within the minimum of 41 milliseconds. It is well below the IEEE 457 standard, which is of 2 seconds. Then performance is analyzed with different conditions of different individual methods. That is first ROC pad has been tested, then IBRPV, and then hybrid has been tested. Now all these three methods are tested for active power mismatch for 10%, 20%, and 30%. As well as same is iterated for the reactive power mismatch. Out of the performance analysis, the hybrid method maintains the consistent load detection time, and compared to the individual methods, that is ROC pad and IBRPV, it is having it is approaching to the speed of ROC pad. Its detection accuracy is very consistent on the higher range, around 95% consistent to detect the islanding. In terms of non-detection zone also, unlike the ROC pad and IBRPV, the hybrid method non-detection zone entirely, which ensures reliable performance even under the challenging conditions of load variations. Then the ROC pad, IBRPV and hybrid method is tested for quality factor of the load faults. So quality factor means it is tested for 1 as well as for different faults. Different IDMs are tested. In terms of detection time, ROC pad has the fastest detection time, but sacrifices the accuracy and then NDZ reliability. Whereas IBRPV is slower but improves the accuracy and reduces NDZ. When we combine these two in terms of hybrid method, it balances the speed, accuracy and the non-detection zone in all the scenarios. As far as detection accuracy is concerned, the hybrid method achieves the highest accuracy, which outperforms the standalone system, that is ROC pad and the hybrid method. This is with regards to the comparison of the hybrid method and the existing islanding detection method. So the comparison is based on the different performance indices. This is part of my research proposal objective 3. So the performance is tested with the parameter like detection zone, detection time, error detection ratio, as well as its power quality impact, and the tested for which type of DGs. So different implemented method I've compared, which have their own performance and their own applicability in terms of DG systems. With regards to the proposed system, so non-detection zone is almost eliminated with the design of hybrid IDM. Detection time is 36 milliseconds. The error detection ratio is 0. The impact is less than 1% just by the operation of the IDM, and it is applicable for the multiple DG. The limitation of my system is applicable for the system with the inverter-based DGs. There has to be a single based DG in the system. Then only this design hybrid IDM is applicable to the system. For the synchronous based the system with the entire synchronous DGs, the design method is not applicable. Now, just to check the performance of simulated system, I've verified this particular performance with the IEEE 13 bus system as well. Similar tests conducted on IEEE 13 bus system as well, as per the previous test conditions. Different islanding test cases are proposed. There is a variation of active and the reactive power for the different power factors as well as the different magnitudes. So there will be a change in the phase angle difference as well as deviation in the frequency. Out of the test what I performed on the IEEE 13 bus system after implementing the design hybrid IDM, the detection time remains well below the IEEE 1547 standards, which is of 2 seconds. As well, the impact of the mismatches. Detection time increases with the greater active and mismatches. As these introduce more dynamic changes to the system, the method effectively handles extreme cases like change in active power is 10% to the lagging power factor, and the change in the active power as well 10%. Similarly for changes in the reactive power as well. With regards to the resonance frequency, the values are stable across all the scenarios, indicating the system's consistency with the dynamic responses. Then the few different quality factors, the system is tested, ranging from 2.5 to 1. 2.5 is the highest value as standards, and the lowest value which I have considered is 1. So here also while varying the quality factor of the system, getting the results as expected. That is detection time is low as compared to the standard values. Then the resonant frequency increases, indicating greater system inertia and the damping. The system sensitivity remains effective across all the values of quality factor with detection time below the IEEE 1547 standards. Similarly, the values of TSD from 2% to 5%. In this also there is very less impact onto the detection accuracy of the hybrid IDM. Then also negligible in the resonance frequency, and it is robust. Though we are introducing or though we are working with the lower values of the power quality. Then the multi-DG condition is also been tested. The detection time in this regards is 100 milliseconds. So though the detection time in this case is higher to the earlier results, it is also below the IEEE 1547 limits. Then resonance frequency and the robustness is also same as per the previous observations. Then it is tested for some of the non-islanding cases, that is induction motor switching, capacitor switching, connection and disconnection of the load in the system. Here also we have received similar results. That is, detection time is very low as compared to the standard. Frequency is not impacting much, and it also avoids the false positive. That is not to detect the islanding false positive. It is ensures that islanding is detected with the design hybrid IDM for the hybrid microgrid. Now I've compared the design hybrid IDM with the existing hybrid IDM. So here also the similar results we have received. There is very negligible impact on the power quality. NDZ is low. It is applicable for hybrid AC/DC microgrid, and the detection time is 93 milliseconds. With regards to the comparison, the detection time, the maximum value which we are getting is 93 milliseconds, which is very low, below the standards. The power quality impact is very low. That is 0.7%, which is well below the one of the implemented method which is having impact on 6%. The non-detection zone is eliminated, and its applicability, as I have mentioned already, the applicability of the proposed hybrid IDM is applicable for the hybrid microgrid with the minimum of one inverter based DGs, as well as AC microgrid. These are the few future research directions with regards to the work which I have carried out. So with regards to the technical capabilities and grid integration, it can be tested with the newer and updated conditions of the grid connectivity. It also can be combined with edge computing as well as cognitive and neural computing. Real world reliability also needs to be considered, which will be important aspects in the future study. Economic viability as well as simulation realism is also proposed as a future direction for my proposed work. I've published two conference presented and published two conferences. Published two journal papers. One is in Q1, another one is Q2. I also published a patent based on my research work, and also one paper is communicated to the Q1 Viva Science journal. Yes, sir.
Thank you.
Yes, thank you.
Mangesh for detailed presentation. First time experts. There's some doubts.
Sir, we are happy that we have this type of sir. We are blessed. He has done hard work for implementing models. Whatever we were saying, he was very listenable to that. And even though the numbers were also very supportive, and they were giving very good comments, and he was always trying to implement those comments. So it is. I think so. It is decided in this.
And the course of provision of this one. On the starting we are consistent work. Whatever the suggestions, proper way. The communication. Even though there is one objective in which that was one which because he has hybrid. So why he has used that kind of hybrid others method also he has compared. So that means that was what was safety that you have to do it. Otherwise that will not be able to verify these two methods. So whatever you were saying was following that. Whether we have direction or not.
I will say.
So he was a member, and
And how did you solve the observation?
My observation is actually very hard work. All time panel member of in company institutions.
Let's first your basic. I will start from basic and then go to the next.
Yes.
So first, can you give me the difference between simple grade we have as compared to the micro? What are the basic borderline which says this is micro?
Okay. In terms of handling power, we can differentiate the grade. In terms of resources, DG sources also, we can say that this is the microgrid and the grid. Means to have the microgrid, at least one DG to be there in the system, which will provide power.
Install in our campus.
Yes.
If it is a microgrid.
Yes, it is a part of microgrid. Unless we are having the isolation, integrity and the microgrid.
No. We have a unit coming and we have an easy set.
Yes.
Whenever there is no supply which is coming from utility grid, we switch on the DG.
Yes.
It is a microgrid or it is something else.
Yes. If we disconnect it from the utility grid, it will be working as
I am not.
No, not like island.
I'm just the borderline to say that this is a micro.
Yes, sir.
If these thing is present, then it is a micro. If this thing is not present, this is not a micro. As per your understanding, what is the borderline? Because he cannot say microgrid is separate and grid is separate. When we see we are interconnecting, what is the borderline or line of difference? Say it will not be counted in the grid, only counted in the micro.
In terms of handling power.
If it is necessary to have a utility connected to a microgrid.
Not all the time. Not all the time. As in there is an exchange. I mean, there has to be exchange of power. Whenever there is excess power in the microgrid, that has to be added to the utility grid.
This we have an island where we are generating the power and we are utilizing that island only. There is no external power connection to that island.
Okay.
Then what is that system?
Also can be treated as a microgrid.
If it is necessary to have a renewable source in the microgrid.
Yeah. Yes.
It is necessary to
Not all the time.
No. Necessary or no? Yes or no? Simple answer. Yes or no?
No.
If it is necessary, then yes. If it is not necessary, maybe or may not be the case. Always there.
No, sir.
If it is. Now you say we have a highlighting mode. That is your basic data.
Yes.
When the supply disconnects through the DG. There is a device which is available in the market. Detects and switch on the DG. You are aware of that?
Yes.
What is that?
It is part of the inverter itself.
No. Simple. We have a utility supply coming. We are using that utility supply. Whenever the utility supply disconnects, we have a diesel generator installed. We will connect that that device which will detect that utility is not coming, so we switch on the DC. What is that device? On which principle it works?
I don't know exactly the name of the device, but it's the principle.
On which
It is continuously checking the signal from the utility.
which principle?
I mean, that is continuously checking the
How? There will be a method on which it will be detecting.
I don't know. No.
It will be a flux
Up.
detection. Similar like in MC. What is the principle of MC?
Same.
So if that is present, what advantage we apply? That is also alternating mode.
Yes.
That also
Exactly.
If we have a device that is doing that work, what advancement you want so that system cost, you say performance, you say anything else. What are the basic improvement you want to make the system by introducing this hybrid method?
This method is specifically designed for, with the conditions in the hybrid because there are multiple generators and the multiple loads as well. And even energy storage systems are there.
You say that phase angle change when we have why?
If phase angle changes when utility grid disconnect a large load of the utility as it is still connected, large load of the utility grid comes onto the DC.
I make it more simpler for you.
Yes.
Now we have a solar installation in this over house.
Right.
We have solar system is there, and we have inverter which is also present in the house. We have MICROGRID also.
Yes.
And some PG also. That is the basic case of your MICROGRID.
Yes, exactly. Yes.
So now when we see we have a utility coming, and we have solar power also. Which supply we utilize?
So load is connected at the PCC.
Load is connected. Load is always
connected at the PCC.
No, we have three supply which are there. We have solar supply, we have inverter supply, and we have the DG supply.
Yes.
And we have utility also. Four types of supply is available. How we will be utilizing that in microgrid set?
So the power is fed by the DG to the common where the utility grid is also connected, and from that common point the power has been distributed to the load.
So why if suddenly the utility power is not why phase change will occur? Phase angle will change.
Because grid load will be there on the DG suddenly.
No, there is no grid load.
No, as there is electrical connection in PCC and the utility grid.
How that?
See, unless we are disconnecting electrically, the DG used to conduce the power from the DG to the utility grid as well.
So that means you are giving supply to the grid.
Not to the local load.
But how this grid load is there? Understand?
No, I understood, sir.
You can on that diagram. I this diagram. Take back.
I'm having a simple diagram. Yes.
You are just left hand side diagram. You have the green dot is
DG.
Lower side is
Grade. I mean local load.
and that is
Grade is utility.
when this isolating mode will happen. When this switch will be off.
See, initially the switch is off. Initially means normal working condition.
Normal working condition switch off.
Breaker off means closed. Sorry.
That's why I'm saying I'm just asking things, not. Don't be afraid. Simple question is you can say it is on.
Yes.
When we say the isolating mode, we disconnect this. Then isolating mode.
Yes.
If this is not connected, how this grid load will be connected to this micro?
So when that breaker is closed, that grid load in terms of LG and RG is still electrically connected. When
That is the local load.
Local load is on the left hand side, so bottom. The LG and RG is also there. Just besides the utility grid.
So where is this grid load? Where is the
DL1.
No, this diagram.
It is there. Grid impedance.
So grid is disconnected.
Sir, load actually.
Isolating will be at the generating station.
No. DGN.
At your series not disconnected from that DC.
Yes.
So that means your transmission line and your generating has been disconnected. So that part load also
Yes.
has been disconnected. Now your diagram is only this part. This green,
Yes.
DC,
And
this and this.
Yes.
So from where this grid loads connects?
Sir, at point of common coupling, there is a connection of utility grid, local load and DG. In a normal condition, all are connected electrically. Right. In
asking for
yes, exactly. When utility grid stops to supply the power in that particular area, right? So with the design IDM will detect that utility grid is
No, I am not asking for detection. I am just asking why phase will change.
Phase angle just because of grid load comes into the picture. Sir, actually, I am shown a grid load there. In terms of impedance only it is there.
Last. You have a diagram of the testing diagram.
Okay.
No, this.
Yes, this is also
again, no, all simplified.
13 bus.
नहीं है.
13 buses.
This.
Yes.
That is the disconnect. CB.
Yes.
So now there is a great microgrid setup is there. Utility setup will be disconnect.
So in this
diagram,
can I show my simulator system?
No, in this
actually the load is not visualized in this particular diagram.
So why your super capacitor? What is the need of super capacitor?
Supercapacitor in terms of storage device.
So there is a storage device. Fuel cell is there.
It will generate.
Fuel cell is storage device.
here actually just beside the islanding CB connected grid load. So in the normal condition, the islanding CB is closed. When there is islanding, still the islanding CB is closed in the initial part of islanding. Whenever there is detection signal by the say detection method, then only that breaker will be get open.
I am not saying this what is actually happening after that. I am asking why that is happening.
नहीं सर.
सिस्टम में ऐसा क्या हुआ कि फेज एंगल चेंज हुआ. लोड तो उतना.
So what I understood is when there is a sort of outage on the utility grid, so it stops to supply the power to the say microgrid and all. So but still it is electrically connected to the microgrid. And utility microgrid doesn't know.
Then that means you have islanding mode.
No, still unless we are not separate, we are not opening the islanding CB, there will be no islanding.
What is meaning of islanding?
Islanding part of the system separated with at least one DJ connected, which will supply to the local load. So as per
meaning of island. That is different case you are considering. That is the case of load reversal, which you are considering.
Load reversal.
We have a supply solar well setup, and we are supplying power to the grid. You are considering this case. That is not islanding.
So unless we are not considering it is islanding.
If breaker is not disconnected, how that say that supply is not from micro. Sorry,
electrically disconnecting.
You claim that you have your supposed system on AC and on DC. AC system.
Yes.
You claim. On what system you are analyze this? Have you analyzed on DC?
No, I have checked the hybrid micro where both sources are there. But there should be at least one inverter based. Then only my system is active.
Then it is not your system is not working on AC and DC.
No, it is working with the AC.
It is working on hybrid system. It is not working on DC system.
Individual DC it won't work. Even I have claimed that as well.
No. So that definition writing is somewhat issue. Because
it works hybrid and AC where inverter based DGs are there.
You say that you have AC, DC. So that means your AC will also work on DC.
No, I'll correct it.
And you are selected value of KPI. How you are selected?
I'm not getting.
You are selected value of KPI.
Yes.
PI inverter controller. You are selected KPI 1000.
Yes.
How you select? Why KPI not 100? Have you tested it?
Yes. I've tested it and tested with even the multiple values as well.
What is the effect? What is the effect?
It's impacting onto the gain of the regulator.
No. If we increase the KP, what is the effect on the
impacting onto the damping.
Increase or decrease?
Increased. Increase.
Have you considered the load reversal?
No.
Why? That is the key answer to your case.
No, load reversal.
Suddenly load is from 100 to minus 100.
Load switching of
Load switching is different. Load is from minus 100 to minus 100.
Not. I haven't
Because that was similar to your case where phase angle change. If that your system works on that, then it is we can say that is working. Unless we have tested on this where the phase angle is not happening. All the cases which you have analyzed your system is the cases where there is no phase angle change taking place. Suddenly load is changed from capacitive to inductive. If your system work fine.
Yes. Because it is a combination of both methods, active and passive.
When the system which you perform, you are claiming your analysis time is 93 milliseconds. But there are many methods which are having 5 and 10 milliseconds.
Yes.
Now you say your system is better than that.
In terms of non-detection zone, it's almost negligible non-detection zone I've got through.
Have you tried any machine learning method?
No sir. Proposed for the future.
Because machine learning gives much far better than just here to be on. That's why we are now choosing to this approach. Some of the question which the expert First question, simple question. What motivates you to choose this particular topic? Why you selected this? What is the basic challenge which we face?
So right now what companies are facing challenges as and when there is a intentional or unintentional outages onto the system. Some portion of the system or the person working with the system they are not knowing about there is a like outage either intentional or unintentional outage onto the system. That's the one concern as well as protection issues when connected in the power system.
From what?
From
protection of system
reclosing means as and when there is a frequency change happens in the system.
Anything else?
In terms of quality also it is impacting. As and when switching in the system it is impacting on the power quality.
But when we talk about renewables, we don't focus on this power quality more. Because renewable systems cannot have power quality.
No. From the source it is not impacting. From system it is impacting.
What is the effect of that if your load get harmonics?
Impacting onto the
your microgrid detection.
It's not impacting much. Tested a lot for. I mean switching as it is not means it is not TSD also in terms.
Have you seen the load?
Yes. 5% have introduced.
Where?
Sure.
And what is the effect of that? We have solar power which we are having harmonics.
Sorry, sir.
Solar panels, wind power that generate a high harmonic signal. What is the effect?
As I've tested with the 5% of
Wind power direction suddenly changed. Wind direction suddenly changed. What is the effect of this? Your eye? Great action.
No, sir, it is not impacting on the design idea. IDM will not detect as islanding. Because islanding requires to be combined these two methods. So unless there is no deviation under the utility connection of the frequency parameter,
frequency change na.
but as utility grid is connected, it is not impacting to the that particular effect.
आइलैंडिंग में तो है ही नहीं.
That is the normal grid condition. If one source is
Suddenly yes, disconnected. At same time your power also direction also
reversal. I haven't tested.
If that will minimize the phase change or not.
I haven't tested.
What is your thinking? It will change or not?
It is impacting.
What is the limitation of this work?
Limitation is, as I mentioned, it is applicable for microgrid, which contains at least one inverter-based DGs.
So it is written in this. This is
Yes, sir.
where? Limitation. Then third is now we have more load of electrical systems is coming. How we can incorporate that in your work? How that can be incorporated? You have not incorporated, but how that can be incorporated?
Specifically work on the design of IDM. Which we can
because load is part of microgrid.
Yes.
If load is electric vehicles. Electric vehicle load incorporated in that. How that can be incorporated?
That what you are thinking.
Sir, if there is a change in the load actually, irrespective of the changes in the load, my design method will work.
What challenges for implementing the model in real world? Because this is simulation. If we want to implement real world, what is the challenge?
Challenge is first of all the implementation of hybrid microgrid, and then
hybrid mic nowadays easily available. Many research institutes have that microgrid.
Check out on the also or basically one type of either season or
we can test it on AC. One Why to test it on both?
Because hybrid circuit can be hybrid
Working on hybrid micro or it is working on hybrid method.
Both.
If it is not working on
It will not work for DC.
If we want to implement, what is the challenge?
No, we can test it.
How physical device will be prepared? For what will prepare a device
Based on
your hybrid method?
Yes.
How it will be implemented? How it will be made?
Yes. With the controller we can have a circuit and we can add it to the design inverter, sir.
If you have more additional work you will do.
Sir, I received the comments from the reviewer. So where are
If you have more time
yes.
work on this, what now you will do? What part you will do?
step. After completing the design,
Actually, I'm currently working on the aging impact onto this particular design method. Means if aging components are considered, what will be the impact on design hybrid IDM?
And why this islanding detection is very important parameter? In case of microgrid.
Because unless there is no disconnection from the part of the grid from the utility grid.
I have a installed setup which will do the work of controlling the effect of islanding. What is the need for detecting?
So if you are not
Like you have done a speed control. We have a speed control. Suddenly the same system controller will start functioning, and it will control the output. The same method why we want to detect, why we don't want directly to control it. Why we have to detect?
with the disconnection we are changing the control, sir. With the disconnection.
No. Simple is we have a DG.
Yes, sir.
There is change in DG load. DG will automatically adjust it. That is the
Exactly. Yes.
So it will detect control.
Yes.
So that is part of your controller setup.
Exactly.
Why there is a separate IDM this one?
Yes, sir. DG will operate with design.
An example. Why is separate detection device is needed? Because controller will do whatever the effect of that change.
Yes.
Any kind of change happening in microgrid that will be done by the control and your load will be adjusted according to the setup. Because there is island which is happening if you have solar installation. Solar is giving power or solar is not giving power.
Yes.
Your controller will adjust according to your if solar is available it lies solar is not available it lies other source.
Yes.
There is a controller which is functioning which is working on the basis of there is a change any kind of change will take place. So then why this detection method is required?
So controller do have its own limit to the source. Beyond the source limits, source cannot deliver. Though we have in the controllers.
So have you tried without IDM, what is the detection difference? You have only controller installed, and you have IDM with controller installed.
So up to the certain limit, the source can provide the power.
No. What is the time of controlling is, if we have IDM control in 1 minute, if we don't have IDM, it will control in 1 minute. If I have IDM installed, it will control in 50 seconds.
Yes, you are right. I haven't checked with this. And with controller and with separate.
The mission why integration is important. Different set of devices required. What is the major challenge of islanding mode?
Major challenge is with regards to non-detection zone.
What key performance metrics you have considered?
Non-detection zone, detection time, impact on the power quality.
They are IEEE standards or you have
No, these are the standard performance indices.
What is the limits for them?
As far as time is concerned, seconds is the limit. Non-detection zone in terms we won't set limits in the defined standards. But as much as minimum that we have to detect the
What is the limit for power quality?
power quality 5%.
5%.
Yes, sir.
And if your system doesn't have any kind of this device and then all of that, what is the TSD we have got without your setup?
Without IDM. What initial system is having TSD below 3%.
So this below 3%, then what?
No, sir. That is to the design
standard. Because you compare your result with the setup which don't have IDM. Nowhere the result.
Right. So
how we can analyze the system performance if it is fine or not?
Yes, exactly.
You have to
No result.
you have to compare the result with.
I think
No, assuming one of the hybrid was implemented.
No method is there. Simple microgrid and then islanding happens.
initially
So that is
Initial what is the TSD? But in this not given. No, but when we compare how we decide system is better or not. But without IDM was very simple. We have a device. We want to improve that. How we can judge that this system device performance is improved or not? So we have to first present the case without any kind of device, then various devices, and then propose device.
Yes. I have measured without any idea of that is 2.8%, and with the IDM it's 0.7.
That must be
Yes.
Any stability issue in island?
No, it is not impacting. It is stability.
But you must have the effect of islanding on stability.
I haven't analyzed.
Or islanding, what is the effect of that renewable energy?
No, on source it is not impacting.
And you are not mentioned which software you have used.
MATLAB.
Where mention it is mentioned
in the report. Yes.
and how you validate your results. Simulation results you get, na?
Yes, sir.
How you validate that you get the right results.
Sir, 13 bus system of compared.
You get same results as
No, sir.
higher system.
No, actually, I have received higher detection time.
No. Your system is getting result is okay. But unless you say that my simulation is correct or not, how you analyze your simulation is correct?
Because I'm getting the results well below the standards. Yes.
Because this design a system which is so base paper you have run that base paper.
Initially we have checked with that.
So where is the result?
That results come directly.
Comparing with base paper or basic method and then your proposed method.
Yes, sir. I've implemented individual ROC IBR and then hybrid.
So what is the economical and environmental benefit of your system?
With regards to the environment,
economical cost related and then
as there is effective detection of the islanding utility grid is disconnected. It is impacting the continuity of the local load. As well as environmental. It is not impacting the environment in terms of its implementation.
That's why I'm saying you have done work you are not able to properly explain or not able to properly write down on this. Your work is but unless you have something compare it with something you cannot say my system is better. And you have presented this table. You are write down references.
Yes.
Which is method? What is the method?
No, based on the parameter.
Which method it is used?
In the earlier table I mentioned.
Where? I'm just asking you this comparison table.
It is there.
You have written 215.
These are the methods.
No. Where is this? 215 where? 215.
There I haven't mentioned about we have compared with the parameters. Here,
How say that how comparison can be done without mentioning the method?
this thing only have compared.
No, method is not written, na.
No, there are
Add methods. Then you can compare how say 2151 pattern only on the basis of parameters. Then must be similar scales 7.5 cycles. Half cycle.
have it into times of time.
All must be same.
Yes, sir.
If it is seconds, all must be then we can compare. Here you are small, like 7 cycle, half cycle.
No, I'll correct it.
Change it. Just write down the limitation.
Yes.
You write down where it must be highlighted. And change this. Where is this IDM device? Block diagram. Combine.
Combine.
This is converter. This is solar PV.
Yes.
Bidirectional. Then you have wind turbine. Diesel. Solar. Then wind not there. Diesel का है, fuel cell का भी नहीं है.
Simulation like that.
And you are that IDM.
Yes.
Where is that IDM?
No, sir, it is not there right now.
So okay. Thank you. You are well. Basically study whenever you are research in case of good quality, but you have to
Yes.
presentation is also important.
Yes.
So for the final word.